Okay, let's unpack this. Welcome to the deep dive. Today we're taking a close look at North Carolina's surprising journey in solar energy. We're exploring how the state is not just embracing sunshine, but actually innovating to turn some unique environmental challenges into, well, into powerful new solutions.
North Carolina truly is a fascinating case study. You've got this potent mix, right? Loads of solar potential, obviously, but then you also have frequent rain, high humidity, and even, huge amounts of seasonal pollen.
Yeah, pollen. We'll get to that.
Right. And each of these things poses real hurdles for keeping renewable energy generation steady.
And it's a state that has been pretty serious about solar for a while now. We're talking, what, over 1,088 megawatts operational way back in 2014?
That's right. A national leader, really.
And a big part of that growth was driven by policies like the Solar Access Law. That's the one that basically cuts through HOA restrictions.
Exactly. So if you want solar panels on your house, your homeowners association generally can't block you, which is pretty helpful for adoption. But, despite that impressive amount of solar already installed, the state's climate throws up some serious efficiency challenges.
Right, the PV efficiency, how much sunlight actually gets turned into electricity.
Precisely. And rain, for instance, it just hammers that efficiency. There was a 2025 study in Raleigh. It showed a staggering 90% drop in daily energy generation during stormy weather compared to clear days.
90%? Wow. That's basically turning them off.
It's a huge liability when you're relying on that power.
Okay, and here's where it gets really interesting, like you hinted. Beyond the rain, there's this other kind of hidden hurdle.
Pollen.
Yeah, the pollen problem.
Think about springtime in North Carolina, all the cypress, pine, oak trees, just releasing clouds of it.
And it forms this thick, sticky layer right on the panels. It actually blocks the light.
Cutting efficiency by how much? I saw a figure.
Up to 15% during that peak pollen season, which is significant. Okay, so why is pollen such a pain compared to, say, regular dust? Dust washes off, right?
Well, yes, mostly. But pollen's different. It has this tough, sticky outer coating. It's called the exine layer. And that makes it incredibly resistant to just being washed away. Even heavy rain doesn't fully clear it.
So rain doesn't solve the pollen problem?
Not entirely. A 2023 NREL study, they found that even after significant rainfall, utility-scale plants only got back maybe 60 to 70% of their pre-pollen performance.
So you're still losing quite a bit.
You are. And economically, if you don't deal with that pollen buildup, you could be looking at annual production losses of around 10%.
10% annually?
Yeah.
What does that translate to in, dollars?
For every megawatt installed, that's roughly $15,000 to $20,000 in lost revenue per year.
Okay, that's serious money. So you've got these persistent issues.
Yeah.
Rain knocking out power, sticky pollen reducing it. What if? What if you could flip that?
Exactly. What if the problem could become part of the solution?
And that's where these triboelectric nanogenerators come in. 10 cheese.
TEMS, yes. It sounds like science fiction almost, but it's real. Imagine tiny generators built into the solar panel surface that actually generate electricity from the kinetic energy of raindrops hitting them.
So you're harvesting energy from the rain itself.
Precisely. It's a completely different way of thinking about energy harvesting. And the tech's advancing fast. Recent multi-layered 10 arrays, they've hit 24.89% energy conversion efficiency.
Wow.
Producing up to 200 watts per square meter during intense rain.
200 watts. So during a downpour, when your solar output tanks.
The tang part kicks in and starts generating power, enough to potentially charge devices, maybe feed a bit back to the grid. It complements the solar perfectly.
That's incredible. Are there real-world examples yet?
Well, there was a 2022 prototype. It achieved 95% wireless charging efficiency for e-bikes using these hybrid solar tang panels. So the potential is definitely there.
So bringing this all together, what does this mean for building a more, resilient energy future, especially in a place like North Carolina with its specific climate?
Well, the state's policy framework is supportive. They have that renewable energy portfolio standard.
Right, the 12.5% renewable target by 2025.
Yes. And they're also incentivizing new tech. There are even tax credits for homeowners who install residential 10 systems, about 50 cents per watt, I believe.
Encouraging early adoption.
Exactly. And the innovation pipeline looks exciting, too. Researchers at Duke are working on these hydrophobic nano coatings.
Hydrophobic, so water repelling.
Right. The idea is they could make panels shed water and maybe even pollen more easily, potentially cutting manual cleaning needs by 70%.
That would save a lot of hassle and cost.
Definitely. And looking bigger picture, NREL is collaborating on a project to install 10 megawatts of these solar tang hybrid farms in coastal North Carolina by 2027.
10 megawatts. That's a decent scale.
It is. And the goal is a 30% increase in the total annual energy yield compared to just solar alone.
30% more energy just by harvesting the rain, too.
That's the aim. These are concrete steps, towards making energy systems tougher, more reliable for you, for everyone connected to the grid.
It really is a powerful example, isn't it? North Carolina isn't just putting up panels. They're actively tackling their specific environmental challenges head on and turning things like rain and pollen into opportunities for, well, more diverse and sustainable energy.
And thinking ahead, the real magic might be in integrating all this solar, Tenians, maybe predictive AI to manage the grid flows based on weather forecasts.
Using AI to optimize it all.
Exactly. That kind of integration will be absolutely crucial for hitting ambitious targets like North Carolina's goal for net zero by 2050.
So it's not just about tweaking panel efficiency anymore.
No, it's much bigger. It's about designing a fundamentally more resilient, more adaptive energy future for all of us. It kind of raises the question, doesn't it? How many other problems could actually become energy solutions if we look at them differently?